Question number 8 asks us to solve a linear inequality by graphing. So what we need to do first of all is to remember that in this process what you're going to be doing is you're going to be drawing a boundary line first, and then you're going to be choosing a test point to decide which part you're going to be shading on the graph paper, whether it's the part above the line or below the line. So let's look at a specific example. Let's look at the one for the question on your review here, and I've got it for you here on my graphing board. All right? So here's our inequality. The inequality is y is less than 5x minus 3. Now, basically, we already have that in the form y equals mx plus b. We're going to kind of just pretend for a minute that this says equals and help us graph the boundary line itself. I know that doesn't say equals, but let's just pretend it does. If it said y equals 5x minus 3, the y-intercept of your line would be negative 3. So we would find negative 3 on the y-axis, which is an ordered pair, and we would put a dot there. The slope of your line, which is in front of the x, is 5. And remember, when the slope is a whole number, you put it over 1 so you can count with it. So if the slope is 5, that tells me from any point on the line to get to another point on the line, we would go up 5 and then 1 to the right. So from my y-intercept, I'm going to use the slope. I'm going to go up 5, 1, 2, 3, 4, 5, and I'm going to go 1 to the right, and I'm going to put a dot there. Now I'm going to connect these two dots, but I'm going to connect them with a broken line. And the reason I'm using a broken line or a dotted line, which is my boundary line here, is because, oh, sorry, that line's not the most straight line in the world, but you'll just have to forgive me. It's supposed to be a line, okay? Close enough. The reason it's dotted and not solid is because this does not say less than or equal to. It just says less than, which means that the points on the line are not included. Now, what we have to decide at this point is whether the solution set is going to be the set of all ordered pairs above the line or below the line. And the way we find that out is by using a test point. The best test point to use is the ordered pair 0, 0. And I'm going to plug that into the original inequality. The only time you can't use 0, 0 as a test point is if the line itself runs through 0, 0, in which case you just used another test. You should just pick a different test point. Just make sure that your test point is very clearly in some region. If you pick it too close to the line, you may be testing the wrong region. But 0, 0 to me is pretty clearly in this upper region. So we're going to use 0, 0 as a test point. I'm going to plug 0 in for y, and I'm going to plug 0 in for x into my inequality. And that actually gives me the statement that 0 is less than negative 3. 0 less than negative 3? No, it's not. So that means when I use my test point of 0, I got a resounding no. And what that tells me is no, don't shade in the portion of the line in the direction above it, because no, those ordered pairs don't work. If the no's are on this side of the fence, the yeses must be on the other side of the fence, and your goal with these problems is to always shade the yeses, because what yes means is yes, we are solutions of that inequality. Thank you.